Welcome back. We're going to look at quotient rule in this video. The quotient rule gives us a way to take the derivative of a function involving the quotient of two groups of terms. Sometimes it could be a singular term. Let f be a function that's a quotient of two terms a and b. And when we talk about that, we're going to have a numerator and a denominator. And those numerators and denominators can have a single term, or they can be groups of terms. But we have a recipe for taking the derivative, and it's called quotient rule. Now, the numerator is going to look much like the product rule did, where we have the derivative of the first times the second, but except we're going to have a minus sign. And instead of having first and second group, we're going to have numerator and denominator. In the video, I'm going to say top and bottom. It's just brief and right to the point. But this is the recipe. So we're going to take the derivative of the top times the bottom minus top times derivative of the bottom. And this will all go over the denominator squared. Let's do an example. Find the first derivative of the function. And we're going to have a function defined as 7x plus 4 over 8x minus 5. Following the quotient rule, we will have derivative of the top, which is 7, times the bottom, 8x minus 5, minus, then we have top left alone, 7x plus 4, times the derivative of the bottom, which is just 8. Now, if that's a constant, you can choose to move that 8 to the front. Just remember, we're going to need to keep a minus sign when we move it. So that's why you see an 8 struck back here, but written here. 3 times 2 is the same as 2 times 3, so 7x plus 4 times 8. If the 8 comes first, we're still going to get the product. Due to subtraction, we're going to distribute a negative 8. But all this will be on the top of the denominator squared, 8x minus 5 squared. Let's distribute across the top. We have 56x minus 35 minus 56x minus 32. Combining like terms, 56x minus 56x goes to 0. Negative 35 minus 32 more, that's negative 67. Our denominator squared can be left 8x minus 5 quantity squared. There's nothing wrong with that. If you choose to write this twice and FOIL it out, after combining like terms, you will get these three terms. In my opinion, you don't have to go any farther than this squared. So this fraction here would be my answer that I would put into WebAssign or on paper. Find the first derivative of the function defined as x squared over x plus 9. Derivative of the numerator or top is 2x times the bottom left alone minus top left alone times the derivative of the denominator or the bottom, which is 1. 2x squared plus 18x minus x squared all over the denominator squared, x plus 9 quantity squared. 2x squared minus 1x squared is 1x squared plus 18x. So I'm just combining the like terms of this numerator. If you wanted to write this x plus 9 twice and FOIL it, it will give you x squared plus 8x plus 18x plus 81. Personally, I think this over that denominator is how I'd write it. Pretty much the time you would want to expand your denominator is if it's possible that you could cancel with something in the numerator. Now remember, it's illegal to slash terms that are connected by plus or minus signs, so that's why I did not reduce here. This fraction is not equal to 1 over 81. Find the first derivative of this new function, 5x minus 6 over x squared minus 1. The numerator we're calling A, the denominator we're calling B. And then we'll follow the quotient rule recipe highlighted in teal. I think that's a teal color. Derivative of the top, 5, times the bottom, minus top, times the derivative of the bottom, which is 2x. This answer is totally fine. The reason I didn't simplify any farther on this one is WebAssign. It will take it once you've got it correctly expanded. Now, if you wanted to go further, we would have 5x squared minus 5 minus, now we'll have to be careful distributing here because of this negative out front, we'll have a sign change. So think of it as negative 2x times 5x. That is negative 10x squared minus 2x times negative 6 is a positive 12x. And this is still over our denominator squared. If you wanted to combine like terms, these two would make a negative 5x squared. There's only one x term plus 12x. Only one constant, minus 5. And then we have our denominator squared. If you wanted to write that out, x squared minus 1 times another x squared minus 1, feel free to do that. I'm just going to leave it grouped and squared. And that is plenty good enough. A second example, 5x squared minus x plus 2 divided by 6 minus 5x. A goes to our numerator, B gets assigned to our denominator. Derivative of the top is 10x minus 1 times the bottom, 6 minus 5x. So derivative of the top times the bottom minus top, which that 2 didn't show up very well, but that's a 2. So 5x squared minus x plus 2 stays the same. Derivative of our denominator is negative 5. Multiplying, if we use the FOIL method in our upper left group here, if we FOIL that out, that is 60x minus 50x squared. The inside gives us negative 6, and the last two terms give us positive 5x, positive 5x. In the back, this minus sign and that negative 5, that will make a positive 5. So think of it as distributing positive 5 to all three terms in the parentheses. So that will be 25x squared minus 5x plus 10. And all that is over our denominator squared. Okay, so up here, I'm going to try to simplify. I'm not going to worry about expanding the denominator. Whoops. Denominator quantity squared. There we go. All right, so direct your eyes at the bottom, negative 50x squared plus 25x squared. That's negative 25x squared. 60x plus 5x minus 5x, that's 60x. And then we have some constants that are negative 6 and a positive 10. Negative 6 plus 10, that's 4. And so that is our numerator with all the like terms combined. And all that would reduce. If you were to FOIL out the denominator, it doesn't lead to any simplification. It gets close, but it doesn't. All right. So anyway, I'm going to end the video here. I hope what I've done has helped you out. There's a video right above this one that's Quotient Rule. It's more handwritten. But anyway, I hope this helps you out. Let me know if you have any questions. Let me know in class, email, and I'll do my best to help you out.